Is CSharpCorner.com too slow? Well, I'm going to do a performance audit of C Sharp Corner and talk about some things that I think they can do to make the site load faster. Some of them you're going to know if you know me, but maybe you don't know the biggest thing I'm going to talk about to make them scale better.
So recently, I know that C Sharp Corner has been going through some infrastructure updates, and I believe they've actually got those deployed to a new system. Basically, they got new virtual machines set up and everything. But just over a month ago, Praveen made a really quick post on the site saying why is C Sharp Corner or why C Sharp Corner is slow. And I don't have any historical stuff to determine what it was back then, but one of the things he does point out here that personally as a web developer I take offense to is that he says download the apps. They shouldn't be slow, which makes me go, what? Because honestly, apps are slower than the web. I said it, okay. But if you program the web wrong, then apps could be faster, but generally they take a long time to load. They're very heavy file size. And something like C Sharp Corner does nothing to integrate directly with the platform. So therefore, there's not a lot of incentive to actually make native apps, to be blunt. This is where progressive web app is more suited. In fact, 99% of the time, progressive web app is the right answer compared to a native app. But that's beside the point. The performance profile for the web generally should be much better than any native app. But one of the things that I do know about C Sharp Corner and performance about this point is the server infrastructure wasn't necessarily keeping up with the demand. And that really points to a scalability issue. Okay, again, some of the things I'm going to talk about here will definitely help you with your scaling without having to add a lot of hardware infrastructure. So in today's world, going big iron is probably the wrong direction. You need to go, um, honestly, I'd say you need to go serverless, which scales nicely, but I'm going to give you a key as we go through this on how you really make your site scale and perform super fast. Now, so by this point, I think they have deployed to the new servers and the new server infrastructure. But I just want to look at this page because what I did was I did a web page test analysis. If you're not familiar with WebPageTest, I have at least one video already posted on the YouTube channel just introducing you to it. But this is my favorite go-to web performance testing tool. And this is the result here. If you go to the home page, all you do is enter in a URL. Must be public if you want to use the public web interface. And then you can select a location, a browser, and all kinds of various things to run a test. Okay. But what I'm going to do, let's just look at this page real quick so you can get an idea. And we're going to come back and we're going to break down the page as I kind of break down where the performance bottlenecks actually are. So just notice it's mostly static. I'll point out a few things that technically are dynamic. It's basically this top corner up here. You got some badge opportunities and a profile set up here, or a login is what it would be if you weren't logged in. Now if I scroll down, this little thing will pop out from the side. And then we've got comments, which in all honesty are not JavaScript related at all. These essentially should be rendered on the server at demand time. And one thing that they are doing that I don't see a whole lot is they've dropped in a third-party component to allow you to make comments using Facebook, which would go on Facebook. And there might be reasons you want to do that. I wouldn't be a fan of that. This right here is something that bothers me. I wouldn't want to see that. But everything else on here is very static, and I want you to keep that in mind. Okay, just keep that in mind as we look at the performance profile. Now, WebPageTest gives you a lot of insight into your site's performance profile. So it gives you a lot of grades. Now we've got ABA up here. We don't have keep alives enabled for something. That's not the huge deal to me. But here's a quick get right here. The images aren't optimized, and you got a D for that. there's not a lot of images on this, so the images that are being displayed, quite frankly, are ads. So one thing they could do is obviously optimize the ads. The other thing is they don't have their cache control header set on some things. So let's just dive into those real quick. And we'll talk about why these are important. So obviously you want to make your images as small as possible. And there's two ways that you need to implement images today. One is you need to optimize them by running them through an image optimizer, like Kraken.io, for example, so you can get the smallest physical size. But the other part of it is you also want to make a responsive set of images and use the responsive image things like source set or maybe even the picture element if you need to do what I call a little more um, image gymnastics with art direction, okay? But there's not a lot of images on here. So like you can see that there's two that are failed and one that got a little warning, but the two that failed are, again, this is an ad, and I'm also seeing like some naming conventions I don't like. I don't like to see spaces in names. They wind up being URL encoded with the space, the %20. That can lead to some issues. Another thing too is you can tell they've got some problems here. They've got an uppercase JPEG and a lowercase JPEG. That's a sign that they need to fix the naming convention piece there. Another thing I want to point out is honestly, always lowercase your static assets for your website. Well, really everything as far as a URL. If you have a system that would automatically just lowercase everything, you're going to have consistent URLs, and you're not going to run the risk of possibly creating two different types of URLs to the same resource. Honestly, the other side of that too is if you've got an uppercase, say in a link that you've created in your markup, but the file is lowercased on the server, most web servers won't do that translation for you and return it back, and that's because technically they're two unique files, okay? So you definitely want to make sure you've got a consistent naming convention. The way I would get around this space thing is I would put dashes or possibly underscores. I prefer dashes. And I have actually have a function that I've written in Node that I use to create what I call a slug name for every file. And it does make sure that all the characters are lowercased and things like spaces and other non-conforming URL characters are replaced with dashes, and then multiple, you know, sibling dashes are truncated down to a single dash, that kind of thing. And I just do that with some simple regular expressions, and it's very simple to do. But you can see here that the image itself is 131 kilobytes, but WebPageTest calculates that you could get this to just under 100 kilobytes. And so basically you're going to save about a quarter of the file size, and that can add up over time if you're talking about scalable. And this obviously is an ad that's going to be shown, several million times a month, to be honest with you. So you can do the math on this as far as just bandwidth cost alone for hosting it. You're going to cut your bandwidth cost by a quarter. Okay, so all it takes is literally a few seconds to optimize that image and make it smaller. And you can make that part of essentially your build or your deployment process. Just make that a step in that process and make sure that that image is nice and small. And you can see we've got the same problem here with this next image. Again, uppercase characters, that's a pet peeve of mine. And this one can be, yeah, wow. That can save 2/3 of that file size. That's huge. Okay, so again, the hosting cost on that alone is more than worth. Just optimizing this one image, I'm sure, pays for, say, a monthly Kraken subscription. Okay, so more than worthwhile. Now, progressive JPEGs, I'm on the fence about that. I don't really care about that as much. But one thing I want to point out here is they're using HTTP handlers to serve images, and I'm going to raise my hand as I'm probably a guilty party of propagating this because over 10 years ago, I wrote a lot of content around HTTP handlers and HTTP modules and ASP.NET. And one of the things to do there was to, resize images via the handler. That seemed like a cool trick to do. Don't do that. The reason is because back then we were like, let's store images in a database. That sounded like a good idea. Terrible, terrible idea. Don't do that. Don't resize your images on the fly constantly. Okay, if you're not, say, Giphy, and honestly, Giphy really should just resize and optimize the images one time when that particular size is requested, and then it's done. Okay, and maybe that's done behind the scenes, but you still got a lot of ASP.NET logic you're going to have to trigger through. So definitely want to avoid doing that, okay? And instead, actually, it's again part of that deployment workflow. Have the images ready to go with the proper cache headers and everything compiled and set on them, okay? And that will help you with your image stuff. Now the other side of it is only half of the 100 static resources have proper cache headers. Notice there's no max age or expires header applied to these resources, and that's a bad thing. And the reason why it's doing that is because you want to take advantage of browser cache. And then if there's no expires headers set, or what we call cache control headers that define how long a browser should cache a resource before checking to see if there's a new one on the server, what you want to do is you want to set a long, what we call a long lifespan or a long time to live. Now, typically on a static resource, if you can muster up a full year, that's like ideal, because that basically means that that file's never going to be requested on your server again, assuming that the browser cache is not purged. Now, granted, mobile devices, which right now is the majority of traffic on the web and will be in the future, foreseeable future for sure, tend to purge their browser cache rather aggressively. So don't necessarily count on that being the case, but it certainly does help. Now remember, the fastest network request you can make is the one that's never made. If the browser, the way the browser requests things from the network is it first checks its browser cache to see if it already has that response. And if it does, and that response is not stale, then it will just return it from cache without making a call to the network. And that's what you ideally want. Now, ultimately, what you really want to do is use service worker caching, but I'm just going to call that one outside the scope of this particular audit and video, okay? So that's what we want to do. So we want to get the cache control header set on these resources. These are all under their purview, so they own these images and these files, so they should be applying a cache control header. Again, that can be part of your deployment workflow and just naturally apply that. My deployment scripts automatically do this based on the file type, and they also will gzip compress based on file type. Now, images do not need to be gzip compressed because they are already in a compressed format. Just keep that in mind. When I say gzip compress, let's limit it to, say, CSS, JavaScript, and other text files, okay? Alrighty. Now, let's go back to our full audit. Another thing it says here is not an effective use of the CDN. Let's go just bounce on that. And I got a feeling that's going to point to some things. Yeah. So C# Corner is not recognized as a CDN, and I'm not really sure if they've got, I know they've had a CDN in front of this, and I don't know if they still do or not, but right now it's not being recognized as a CDN, so we need to work on that as well. And even if it is, then that's fine, but if it's not, then that's why that's getting called out. Okay, now let's look at the next vital piece, and this is the waterfall. This is this graphic right here. And now you can also get a waterfall in your browser's developer tools. It's under the networking tab, and it'll look very similar to this. Now the WebPageTest waterfall gives you a lot more information than what you get in the browser tools, okay? So let's look at the actual report and we'll dive into this. Now, I just drilled into the first run. By default, WebPageTest will make 2 runs. It'll make an initial unprimed request with nothing in the browser cache, and then it will come back and make a second request with the browser cache primed, basically from the first request. That way you can see what a repeat visit might look like. Well, we're going to look at the first one here. And the first thing you want to look at is this time to first byte. And this is a very, very good, very respectable time to first byte, basically a quarter of a second. That's generally what I see from most servers these days. Now this was made from the Dulles data center, Dulles, Virginia, which is in the Mid-Atlantic East Coast, United States. Okay. Now I happen to know that the C# Corner servers are located in around San Antonio, Texas, so you can kind of guess where the data center is now. Okay, but a quarter second's good. Now, if this was longer, that would indicate that there's a problem on the server. So right now there's really not a problem with the server. And this is where most people tend to focus their web performance effort. Now, that's all well and good, and you should have a good server infrastructure that will respond quickly and at scale okay? And a site like this is a site that needs to be at scale. What most people don't recognize is that's only 5% of your web performance profile. And I say 5% because, again, remember, most of the web's traffic is generated from a mobile device, and a lot of times that will be over a cellular network. And the average cellular network in the world is not LTE. It's actually um, intermittent 3G, if you will. I would say good to middling 3G. So you don't have blazing speed necessarily. And when I tell developers, you really need to develop and test your website for relatively slow and spotty 3G connectivity, that's really what I'm referring to. So with that, the quarter second's going, if you get on a spotty 3G, it's going to be a lot longer. Now, if you can get that lower, then that's awesome. The best thing you can do is actually have a compressed piece of HTML coming down that's 14 kilobytes or less. And the reason is the way TCP works is it makes round trips starting at 16 kilobytes and then 32 kilobytes, 64, and so on until it gets about 4 megs as far as the byte size. The last 2 kilobytes of that 16 are reserved for headers. Okay. Now, if we look at this, you can see that the compressed size is 12.9 kilobytes, so that's very good on their part. So we're giving them a good high five on that one. And this also breaks down the different things. 33 seconds for DNS resolution, that's a good number to have. And then the initial connection takes 58 seconds to make it to the server. It has to find out where the server is by doing a DNS, and then it has to connect. So now we are sitting somewhere around 90 milliseconds. And then we've got 120 milliseconds to actually get the content back from the server. Okay. And then the full, that's when the first byte hits, and the rest of the bytes took another 65 milliseconds. Now, if I went through and ran another 20 or 30 runs of this, you would see some variation in these numbers, but not a whole lot. You're still probably looking at somewhere between 200 to 300 milliseconds is going to be your range for this time to first byte. So they've got their server configured rather well right now, so I'll give them big kudos for that. And now the fun starts. Because we got the HTML, the browser now knows what CSS, JavaScript, images, etc. to go download. And that's what's happening. But the page is not actually rendered yet. What has to happen is it has to get enough CSS to be able to render. And it's going to start going through what we call the critical rendering path. And ideally, you're going to limit the number of loops through this critical rendering path. And you do that by minimizing the amount of CSS that needs to be parsed and rendered, applied, whatever you want to call it. And you also need to limit the amount of JavaScript. And the JavaScript's the big hindrance, okay? And that's because JavaScript, A, has to be downloaded, then it has to be parsed, and then it has to be executed to determine if it does any, I call it damage to the DOM, which means that the browser has to recycle back through from the top and start the re-rendering cycle all over again. And that's why JavaScript is a blocking process. And it has to be because of things like document.write, which you should never use anymore, but they're there all over the web because it was there in the past. And that's how we did things, say, before jQuery, to give you a good example. We've got better ways to do that kind of stuff these days. Okay. So we're going to look at the waterfall. Now, ideally, they would be using HTTP2 and also BSSL, which I don't think they are either. No, they are not SSL. That's one thing I would definitely say. Upgrade to SSL and use HTTP2. The page load will be much faster for that alone. And so SSL certificates these days are real free. So they really don't have an excuse for that right now. And pretty much every CDN supports HTTP2 for the transport protocol. Okay, so we can see that we're getting, I'm not even sure what this file is just yet. Let's see what we got here. The first one, let's see what the response type is. User agent, I'm not even sure what type of file this is. I know it's gzipped. Content type, I don't see content. Oh, here we go. It's CSS. Okay, so it doesn't have a CSS file extension. Again, that's not required. The header is what the browser actually used. I could have put any kind of extension I wanted on it, to be honest with you. So we've got a little CSS. We're asking for a little GIF, probably some more CSS, some images, and some font files, all this stuff. Now we're hitting the JavaScript. Okay, looks like we're actually requesting the same file twice. Let's see if we are. Nope, slightly different files, and this is coming from an ad server. Okay, and this is a pixel from an ad server. Things like this, I would lazy load. Okay, defer those loading because that's just going to block your rendering that much more. And again, double click, add stuff, add stuff, add stuff, add stuff, add stuff, add stuff. This is all add stuff right here that's dropping in there. And notice the page doesn't actually render completely yet, right? Because it's being held up because of those. Now I want you to notice there's some lines here on this graph. Okay, so there's DOM interactive. That's when the person can theoretically start, say, touching and moving the page. So this is after 4 seconds. And then DOM content loaded, those are pretty much in line. But here's like the big one, the document complete. And this is when things really can actually start being utilized. Now remember, you've got 3 seconds to be able to work, okay? And if you can't actually be usable within 3 seconds, statistically, you've lost over half of the people who tried to load your page. So the trick is to be fully rendered before 3 seconds. Ideally, if you absolutely can, 1 second, because mentally, that's where people start separating from their task. Okay, all of these files with the yellow row, those are files without content expires headers on them. Typically you see that in add stuff, but we also know that a lot of the stuff being hosted by CSharp Corner doesn't have those expire headers as well. Okay, now you see it's still rolling. It's basically just cascading over, and that's because all those servers are using HTTP 1.1. And then here we're actually finally getting to stuff that CSharp Corner needs to compose from their servers. These honestly should be up further, okay? And we're still cascading over. You see how we're back to ordering C# Corner stuff. All this add stuff, that stuff should be loaded after all of this and in a lazy load fashion. Here's where they're starting to call I think they're calling the comment stuff for the Facebook down at the bottom. And notice how this is lazy loaded. That's actually a good thing, okay? Now I want to point out down here, we've got how much the CPU is being throttled or taxed, and here you're basically seeing it maxed out almost the entire time. You want to keep that as low as possible. The amount of bandwidth being used, again, that's a relative thing right there, but it also lets you know kind of how things are being downloaded. But this is the main thing. The browser does everything in a single thread. And what we have migrated to, unfortunately, is doing a lot of task and stuff that really the browser thread is not really designed to do, and a lot of calculations using frameworks like Angular and React and whatever to do a lot of work that really is not suited well for this thread. This thread's really good at rendering the DOM. That's what it is. That's pretty much what you should limit it to. And because they've recently jumped to about 360 kilobytes of JavaScript, all this kind of uh, goldenrod yellowish color here, the orangish yellowish color, it's actually called goldenrod. Um, that is JavaScript processing. The purple is CSS processing. Notice how limited that CSS is, but look at how much JavaScript is being parsed. There's very little on the page that requires JavaScript. But because they have upped their JavaScript amount lately, this is what's going on. And this is right here, the number one thing that's keeping the page from rendering in a reasonable amount of time is this, okay? And you want to limit that profile as much as possible because JavaScript just takes a long time to deal with. And now I did this using Chrome on a desktop in a very good bandwidth piece, so that's why we got about 5 seconds of load time, all right? And you can see there's a lot more detail here. So what I do want to do, I also ran this from Mumbai, the same exact test, the same exact URL, and let's see what we get from Mumbai. Again, compress images, use static content, and here's the profile from Mumbai. Now, I don't know, this first view doesn't look quite right. Something probably went wrong on this one because that is not correct. I can tell you that right now. So let's go look at the second one, and maybe we want to rerun it here. In fact, let's just do that. Let's rerun it while I'm looking at this. Sometimes this is happening, but with the WebPageTest, I know they've been doing some upgrades on this on the infrastructure lately, but I can tell you right now it's not exactly the same files being downloaded. And I bet that has something to do with the location and the ad networks. I bet they're doing slightly different stuff. Now notice the time to first byte here is a little more than twice what it was from the Dulles data center. Now again, if you had a good CDN, they probably would have a physical presence closer to Mumbai, which theoretically means it should load faster. Of course, it does come down to network congestion and things like that. And you can see the actual fully loaded time, 722 seconds. Now that's obviously bad. And that's, honestly, that's why this waterfall looks straight down. I didn't even notice that. Look at that, 50 seconds, 100, 150 seconds, so forth, all the way out to 700. What is taking so long? Oh, here we go. Yeah, okay, so this is a bad habit too, I see a lot of websites do. They're dropping in external third-party JavaScript code from different social networks to show how many times an article has been shared. Now that doesn't really buy you a whole lot as far as what people really do as far as respecting an article or popularity of an article. Instead, what it does is it drastically slows your page load down, which means fewer people actually read the article or interact with it. So it costs you a lot more than it gains by actually showing those social metrics, so to speak. And this is very expensive. Now, ironically, you got Google, Twitter, and LinkedIn all causing problems because these files are taking forever to download. That's why the page took so long. Now, if we go down here to the CPU, you're not going to get any good resource out of this because it's so messed up because of those. Okay, so that's what happened on that. Glad I caught that one. So that's a bad sign. We don't want that. And that's sometimes why the page will lock up because it's sitting there waiting on something like that. So let's go see if our test history has returned on this one. Maybe the files loaded faster this time around, and it looks like they did. So this will be a more reasonable one. Again, 17.655 seconds. Just a quick note, right now the average load time for the average page on the internet is around 19 seconds, which is absolutely unacceptable. Okay, now if we look at this, it looks very similar to what we saw before. We're seeing an 890 or 834 milliseconds for that time to first byte, and that's bad. Some of the things they could do to kind of speed up some of this third-party stuff is prefetch, DNS prefetch in their header. I don't know, I'll make a video about that sometime in the near future. I would also find out where this is being referenced and remove it because that's a 404 and that's causing latency. And you can see basically it looks the same. Again, here we've got something that looks like from Google Static. These files, this file, this file, these files, these are all taking a long time to load across the pond. Now it looks like the JavaScript load is not near as bad as what we saw in the US. And I got a feeling, again, it comes down to those ad networks and how efficient they're working. There's been a lot more research lately about the impact of third-party scripts on your overall performance and just how bad that is. Maybe I'll point to a few of those in the description of this video. So you can see there. So the number one thing I would say to help their Indian profile, which is very important to C# Corner because there's a very big audience in India, is to make sure that the CDN has a good presence near somewhere in India, if not actually in India. And this will also help with places like Australia, which I know is also another good place for developer traffic. And so we can see right here, the DNS lookup took a while. The initial connection, the time to first byte, there's just a lot of slowness connecting to India. So they need to definitely have a physical location closer to that. So what's another thing that we can do to make this time to first byte even better? Now, I know the C# Corner is an ASP.NET site, and there's nothing wrong with ASP.NET. I was an ASP.NET MVP for like 7 years. I wrote several books about ASP.NET, and I know a lot about how ASP.NET works. And it's no different in the end than, say, a PHP engine or Ruby on Rails or a WordPress engine. The thing you want to do is you want to take them out of the equation from where your website is actually served. Instead, you want to turn your website into a static website and make your CDN point to your static page origin, or your static website as your origin. And if you understand how to set up a CDN, that's more of a DevOps task anyway. You want to point to that static website. And the way these things would work is you'll essentially put a tool in place that will run over your dynamic website, so your ASP.NET website, and render out the text from the actual web server, and then deploy or save that static result to your static origin. And you want to make that something that's going to be automated. So as soon as that, say your data that composes a page or a new page is created, that you get that tool to run over your resources and put those on the static site. Now, one tool that's really popular to do this is Varnish, and I know that Stack Overflow is an ASP.NET site, but it has excellent performance profile from the server, primarily because what they're doing is they're doing that model. Now, I don't know if they're using Varnish or not. I've been told they're not, but it's something very similar. I don't know the exact details, but I do know that they're running a static site tool over their ASP.NET infrastructure, and that is what is deployed when you request a file from Stack Overflow. And they've got this completely automated process that kicks in when content is updated to update a resource. And that is probably the most efficient way to do any of this, okay? And that's what I would recommend for any site, is to have something like that in place, especially sites like CSharp Corner, which get, multiple millions of views each month, okay? And so that would definitely improve their profile as far as the time to first byte. But again, we're talking about the first 5% of your web performance profile. Now, the rest of it is that client-side thing. And the number one thing you can do is reduce the amount of JavaScript you use, because that is what slows things down the most. Now, if you can get away from using JavaScript, the better. Now, what on this page actually needs JavaScript? Let's go back to the actual page and we'll point it out, at least as far as I can tell from looking at it. Again, the badge is up here in this top corner, and the login profile. That's something that would be toggled based on if there is an authentication token present. If there's not an authentication token, then this would say login. So that's a very simple toggle, and honestly, you just change a few little features here. This is something that could be done in just a few dozen lines of code, and the same thing for these badges. That could also be done in just a few dozen lines of code. The next thing that I can tell is this little pop out, and this is based on scroll position. Again, another very simple thing, something that can be done in a few dozen lines of code. Now, the next thing that they're doing is they're dropping in a lot of third-party stuff, and a big chunk of it is this Facebook comment system. I would be curious and actually go through and do an audit. How much is this being used? Because they've got a duplicate comment system in place. And the first one is their own internal one, which may or may not be run by JavaScript. I don't know. But I would make the comments part of the render process and make that available there. And remove this Facebook comment thing, because I don't think it's buying them the added benefits that they think it might be. That would be interesting to see the actual review of that. So those are my little analysis to kind of go along with this. Why is C# Corner slow? I wouldn't necessarily say it's slow. I think it's got a decent profile, but it could definitely improve. I think honestly we could get that load time over a good cable connection here in the United States down to under 2 seconds consistently. And let's try to get that India profile to 3 or 4 seconds or better. Now, I didn't run it over 3G. I'm pretty sure if I ran it over 3G, especially from Mumbai, I think we'd be seeing a very slow experience and something that's not necessarily acceptable. And that's definitely something we need to work on. There's going to be a lot more that we can look at to make that work better. So hey, if you've got some questions or comments or suggestions for C# Corner and their performance profile, leave those in the comments below. If you think this video was helpful for you, or maybe you don't necessarily agree with some of the things I said, Again, leave those in the comment below. If you think some other people might benefit from this, please share this video and with your friends or colleagues so that they can also get some benefits as well. So I want to be able to help everybody make the web a better place, and making websites perform well is a big part of making the web a better place, and that's the #1 goal here. Thanks a lot, and I hope you've enjoyed this video.